Good day, our listeners, and welcome to our today's class. We hope you had a very wonderful night. Today, we are beginning the study of matrix and operations involved in matrix. But we begin with a simple definition of a matrix. What is a matrix? A matrix is a mathematical structure that holds information in a rectangular form, which is always enclosed within a bracket. That is what we call a matrix. A mathematical structure. It holds information or it contains information in a rectangular form that is always enclosed within a bracket. That is what we mean by what? By matrix. How do we represent what? Matrix. Matrix can be represented only when we know a dimensions of what? Of the matrix. Dimensions of what? Of the matrix. What do we mean by dimensions of matrix? What we mean by dimension of matrix is the number of rows in that matrix and the number of what? Columns in that matrix. That's what we mean by dimensions of what? Of matrix. So having known what is called matrix, we are quickly going to look at types of what? Matrix represented with the dimension of the matrix. So number one, talk about what? Types slash dimension of matrix. Then let me say I have number one. Number one, I have what we call M by N matrix. M by N matrix. I'll say where M stands for the number of rows and N stands for the number of what? Columns. I say where M number of rows and N number of columns. Number of columns. Okay? Then we have number two, we have what we call M by 1 matrix. Here, M equals, as usual, number of rows, and 1 now here in this case is the number of what? Column. So that's the reason why oftentimes we just call it a column matrix. So we have number of columns. Number of columns. But equally have number 3 where we have 1 by N matrix. In this case as well, 1 equals number of rows and then N equals number of columns. Number of columns. I repeat, we began by defining what a matrix is. We said that a matrix is a mathematical structure that contains information in a rectangular form that is always enclosed within a bracket. That is what matrix is. We now said, how do we represent matrix? We cannot represent a matrix without knowing the dimension of what? Of matrix. What do we mean by dimension of what? Matrix. Dimension of matrix talks about the number of columns and the number of rows involved in what? In that matrix. And we say, let us quickly look at together types and dimensions of what? Of a matrix. We began number one. Number one, we say that this matrix is called M by N, where M stands for the number of rows, N stands for the number of what? Of columns. Then number two, we have M by 1, where M as usual stands for the number of rows. But it has been established or it is known that in this matrix, the number of what? Of column is what is 1. And we usually call it what? A column matrix. So if this is given to anybody and ask you, what is the type of this matrix? Or what type of matrix is this? It is a column matrix. Column in the sense that it has only one column. And because of that, this name is driven from or is derived from that particular column. Then here we have what? 1 by n matrix. Here it has been known that the number of rows is what? Is 1. Where we have n what? N columns. And because of that as well, we usually call this one what? A row matrix. So let us quickly dwell by looking at this m by n today, as we can represent it, and once people see it, they will be able to understand what we mean by m by n. So permit me to clean these ones. Of course, the traditional thing there is that we represent a matrix with a capital letter and represent the entries of the matrix with the small letters of that capital letter. That's what we do. So, for instance, if we have a matrix and that matrix is matrix what? A. And that matrix A equals, let us say that the number of what? Of column, or sorry, number of what? Of rows is what? 3. You have what? 3. Or let me begin with 2. By, let me say that the number of what? Of columns is what? Is equal to what? 2. Meaning that I have 2 by 2 matrix. Where the number of rows is 2, the number of columns is what? Is 2. Also note that we represent the number of rows first before the number of what? Columns. How do we now represent this matrix? Using the small letters of this uppercase letter A. It is represented as this. We say this equals. You now open what looks like a rectangular bracket this way. Open it this way. Okay. How many rows do we have? We have 2 rows. Come by the side and write 1 and what? 2, because there are 2 rows. How many columns do we have? We have what? 2 columns. Represent it is what? 1 and what? And 2. You have started. You now come. There is going to be an entry here. And an entry here corresponds with row 1 and column 1. And we are using small letter. So I'm going to write what? A here. I'll ask myself, what is the position of this A which I have written here? You locate the row first before you locate the what? The column. The position here is what? 1, 1. 1, 1 here means that this A is at the position of row 1, column 1. You come over here. Then you have what? A written here. What is the position of this A which I have written here? The position is, it is still at row 1, but now at column what? 2. So here becomes what? 1, 2. We come down here. You now write your A here as well. You now ask yourself, what is the position of this A here? At which row it is? Or is it? It is at row 2. At which column is it? It's at what? Column 1. You now write what? 2, 1. You equally write your A here. You ask yourself a question. You have written your A here. What is the position of this what? A? You ask yourself. Which row is this A? It is still at row 2. You now write your 2. Which column is this A? It is at still column 2. You write your 2. So you have been able to represent this 2 by 2 matrix using the lower case of the upper case of what of the matrix. These are what we call the entries of what of a matrix, which equally shows or which equally show the position of the entries. A11 row 1 column 1, A12 row 1 column 2, A21 row 2 column 1, A22 row 2 column 2. We have represented this matrix. Then let us now have another matrix. Let us call it matrix B. Let this matrix B be, I want the number of rows now to be what? 3 by I want the number of columns now to be what? To be 2. How do we represent this one? Simple. We equally come here and write for ourselves our B. This equals. We now do something of this and do something like this. We ask ourselves a question. How many rows are here? There are 3 rows. We now write 1, 2, 3. How many columns are here? We have column 1 and what? 2. And do remember that the moment you use this 1, 2, 1, 2 to locate the position of the entries of the matrix, you clean it off because it's not part of what you are asked to do. So this becomes your answer. So this one you are also meant to what to represent it. First of all, you use your 1, 2, 3, 1, 2 to locate it. You now write it. This time around, don't write A again. It is wrong to write A. Because the matrix here is what is A. That was why we used A here. Now the matrix is now B. We are going to make use of what? Of B. Note that. So here we have what? B. B. We quickly ask ourselves a question. What is the position of this B? At which row is it? And at which column is it? It is at row 1, column 1. 1, 1. Here we write another B. We ask ourselves, which position is this B? Which row is it still? It is still in row 1, but this time around in column 2. We come down here and write what B. Which row is this B? 2. Which column is still 1? We come here and write what B. Which row? It is what? 2. Which column? It is what? 2. We quickly write another B here. Which row is this B? 3. Which column? 1. Which row is this one? This is B. Which row? 3. Which column? 2. And then this is our matrix. 3 by 2. We have represented the matrix B that has dimension 3 by 2. That is how to represent the dimensions of what of a matrix. Okay? Now permit me now to quickly clean this, or before I clean this one, let me even call this one that I have a matrix C. I have a matrix C, and let me say that my number of what of a row is 1. Okay, yes. That my number of column is what? Is 2 by 1. Here, the rows are 2, the column is 1. Then you do something like this. You say that your B equals, you do something like this. You do something like this. You ask yourself, how many rows? 1 and 2. How many columns? 1. So you now write what your C. Small, this is my C, sorry, because I'm using C. This is C. What is the row here? 1. What is the column? 1. Here you come, you write C. What is the row here? 2. What is the column here? 1. This is the type I said is called a column matrix. A column matrix. Because it has only one column. But then when you have something like D, and that D is given as, let me say it is 1 by what? By 3. And you have to represent this D. It is now therefore, my D now is given as this. Is given as this. You ask yourself a question. How many rows do you have? 1. How many columns do you have? One, two, three. You come here and write your D. Position is 1, 1. Write D, row 1, column what? 2. Write D, row 1, column 3. And this is 1 by 3 matrix, which we usually call a row matrix. This is how to represent a matrix. Thank you very much. Today, we just started the discussion on matrix. We continue to bring it up and discuss with you from time to time till everything about matrix and matrix operations in terms of determinant, in terms of the inverse, in terms of every operation you can think of in matrix becomes very simple. In terms of even solving equations or what in matrix, linear equations, simultaneous equations, and the rest of them, or mainly simultaneous equations. Thank you very much. As we have started, please start with us as we are discussing this matrix. Surely it is going to end well. Thank you for your audience for today.